my name is Siti Hawa. So before we start, this is our chosen item, which is self-cooking stove. It is a smart kitchen appliance that combines many cooking functions in one machine. It can chop, mix, blend, knead, steam, cook, and even weigh ingredients. So, how does this product relate to thermophysics? First, the heat transfer. This item uses a heating element under the bowl to transfer to the food. This involves conduction, where there is direct contact heat transfer. The second one is temperature control. It has sensor to keep the temperature steady based on thermal equilibrium and feedback system. The last one is steam cooking. It heats water to create steam, where there is a phase changes liquid to gas that related to latent heat.
To understand the significance of this project, we will identify the components of needs. The first one we have what key need will you meet, whose key needs specifically, how often do people experience this problem and when, how big is the problem for users or customers, for example, in unwanted costs, and what will happen if that need is not met. Our project focuses on three key needs. The first one is heat control. Conduction and convection help distribute heat evenly in the pot and apply specific heat capacity to adjust heating rate based on ingredients. Second one is safety. Controlled heat transfer prevent external surface from overheating, and auto shut-off features avoid overheating or fire hazard. Third one is time efficiency. Faster cooking through efficient heat conduction and maintain thermal equilibrium to avoid reheating cycles. This stove caters to three primary groups. The first one is people with physical disabilities. The integration of rotational mechanism such as automatic steering eliminate the need for manual effort, while thermal control systems ensure the stove maintains safe and even temperature. Second one is for busy working individuals. Self-cooking stove allows them to prepare meals without constant supervision thanks to the features like automated heating control and rotational mixing. Lastly is for housewives who handle multiple daily chores. The self-cooking stove helps to reduce the burden of repetitive stirring and closely monitoring the heat, making long duration recipes more manageable and freeing up time for other responsibilities.
Next, the third component of need is how often do people experience this problem and when? The problem of needing constant attention while cooking is frequent and consistent, especially for individuals with busy schedules. Many people cook at least once or twice a day, meaning they must spend 20 to 60 minutes per session supervising the stove, stirring, and adjusting the heat manually. From what we observe, people usually face this problem in the morning. It is because people are rushing to prepare meals before school or work. They often skip breakfast to arrive at destination on time. Other than that, in the evening after work or classes, people are already tired and want quick effortless meal prep. Manual cooking can feel exhausting, especially for families or individuals that need to managing multiple dishes. Not just that, people that love to do multitasking also face this problem. For example, cooking while handling chores, helping children, or working from home leads to a higher chance of undercooked meals or wasted food. Last but not least, for elderly or physically challenged individuals, even simple cooking tasks like stirring or adjusting the flame can be physically taxing or risky, making the problem persistent and daily. Now, for the second last component of need is how big is the problem for users or customers? For example, in unwanted costs. So, this problem has a high impact on both time efficiency and safety, which can lead to several direct and indirect costs or negative outcomes. For example, wasted food and ingredients. Without constant attention, food can burn, overcook, or spill over that leading to repeated waste and extra expenses. Other than that, it also can increase utility bills because inefficient or overextended stove use can waste electricity or gas, especially if the cooking is not well controlled. Besides, this problem also can cause time loss. The time spent monitoring and adjusting the stove adds up daily. Over a week or month, that time could be used for rest, study, or other productive tasks. For the last one, it also can cause health risks. This because improperly cooked food can cause foodborne illnesses. Overcooking also reduces nutrient value. Additionally, there is a risk of burns or fire if a pan overheats or if oil splashes.
What will happen if the heat need is not met? First, no temperature increase in cooking. In thermophysics, heat transfer through conduction, convection, and radiation is essential to raise temperature. Without heat, the food or water remains at ambient temperature, and no cooking or boiling will occur. And the second one is no phase change. For a phase change, such as boiling water, enough energy is needed to overcome intermolecular forces. Without sufficient heat, ice will not melt and water will not boil. Phase changes simply won't happen. And next, failure to reach thermal equilibrium. In thermophysics, systems exchange heat until they reach thermal equilibrium. Without heat from the stove, food remains cold and never reach a safe or desirable temperature. And then we will discuss about component of approach. First question is, what is your unique approach to meeting this need? Second question is, what is your solution broadly? And third question is, do you have any technical issues to solve? What is your unique approach to meeting this need? First, applies heat conduction principles. Use materials with high thermal conductivity such as copper or aluminum. Ensures efficient and even heat transfer to the food. Second one is minimize heat loss. Use thermal insulation and reflective surface to trap heat. Reduce energy waste and keeps cooking temperature stable. Third one is exchange heat distribution through stove design. Stove burners are engineered for uniform flame or heat spread. Promotes consistent cooking and prevents hot or cold spots on cookware.
Our solution to this problem is to create a self-cooker that is able to cook food without having the user attend to it constantly. The user will only have to prepare the ingredients following the recipe and add all the ingredients into the self-cooker. The self-cooker will adjust the temperature accordingly, and it will also stir the food being cooked, so there will be no need to worry about the food burning. The first technical issue that we have to solve is overheating. The self-cooker will be prone to overheating if it is used for a prolonged amount of time, and it will also overheat if the cooker is not provided with the proper amount of ventilation. The second technical issue that we have to solve is the fact that the self-cooker does not have a frying option. The self-cooker produced would not have a deep frying option since the temperature needed to heat up the oil is at least 190 degrees Celsius. It would be a safety hazard if the self-cooker is left unattended when the oil is at this temperature. In conclusion, the self-cooking stove is more than just a convenient innovation. It's a practical application of thermal physics in everyday life. It demonstrates how understanding and applying thermal concepts can lead to sustainable solutions, especially in areas with limited access to electricity or gas. The self-cooking stove is a powerful example of how physics can shape technology that makes life easier, safer, and more efficient.